Hello viewers, welcome to my channel. We are continuing with the tutorial on the number system, the real number system, and at this you want to treat recurring or repeating decimal. So in these questions we are going to convert them from decimal fractions into a common fraction. That is a fraction in the form a over b. Alright, there are so many methods involved in providing an answer to this. The first one is the mental trick, whereby if you look at 0.3 with a dot on top or with a bar, sometimes a bar or 3 dots at the back, meaning the number we are seeing at the decimal part is what? Recurring or repeating itself. Now you ask yourself, how many numbers are repeating after the decimal point? So in this case, we have only one number, which is 3. So if it is only one number, we take that number as 1 and subtract it from 10 to get our denominator. What I mean is that it is only 1 that is repeating. So I'm going to have 3 over how many numbers are repeating? 1. That 1 from 10. This is the 10th position. 1 minus 10 will give you what? 9. So 0.3333 recurring in a form of a over b is just 3 over 9, which could also be further divided to give us what? 1 over 3. Meaning if I have 0.444 recurring, I ask myself how many numbers are recurring. It is only one number, and that number is what? 4. So we take 1 from what? 10, right? You get 9. So 4 over 9 give you a fraction form of 0.444. Alright. Okay, look at the number 2. What do you see? You see two numbers recurring, right? 424242 recurring. So the 42 is going to be our numerator. Because when I multiply this by, there are two numbers, so I'll use 100. When I multiply by 100, it will send this 42 to become a whole number. Therefore, 42 is our numerator. And I will mention the word 100 because there are two numbers. We subtract 1 from that to give us what? 99. So this is also going to be 42 over what? 99. Just like that. Mental calculation. Alright. Then when it comes to the number 3, if you look at it after the decimal point, we have 1. And that 1 is not part of the numbers recurring. It is only 3 that is recurring. So it means that before we can multiply in our mind to send this to become a whole number, we must first of all send the 1 away. So if before the 1 can go here, it means you are multiplying by what? 10. So the 1 is there, meaning you are now left with what? 1.3333 recurring. So now for you to send the 3 that is recurring to the whole number, that will become 13, right? But because you're going to multiply separately in your mind, 10, it's going to be 100, all right, but your subtraction is not going to be 1 as we have here. There are two numbers, but we take away 1. Here it is only one number, we still take away what? 1. But here, because the 1 is not part of the recurring numbers, if you are going to subtract from your denominator, it's supposed to be 10. So it means my denominator will be 100 minus 10. And that will be what? 90. So now I'll be having, this will now go to become 13. But now 13 minus what? The number that is not part of the recurring will give us what? 12. So the number 3 will also be 12 over 90. It's mental calculation. So first of all, 1 is not part. So let the 1 go. Then you are left with 1.33. Now for you to make a whole number, the 3 that is recurring must be part of the whole number, which will be 13. But you have multiplied twice. 10 times 10, 100. So 100 minus what? 10 as your denominator. Then the 13 minus the 1 that is not recurring. That will give you what we have there. Then let's come here. This is our 1. It's not part of the recurring, but it's already on its own. 15, which is a 1515 recurring. So in this case, it is the two numbers that are recurring, which is going to be 15 over 100 minus 1, 99, right? All right. But for this to go here to become a whole number, it's not going to be 15, but it will become what? 115. Do we get it? This is going to be 115 if the decimal number which is recurring move to the left to become a whole number. It will become 115. You see, when this one move, it's going to be 042, which is 42. But when this one move, it will be 111, which is what? 115. So that 115 become the numerator minus this number that is not there. So I'll be having 1114. Then how many numbers are we moving? It's only 2. There is no other non-recurring number. So you take 1 from our 100 because there are 2 numbers to give you 99. So 114 over 99. All right, I'll be leaving this one for you after I am done everything to see whether you can also arrive at that answer. That is one aspect. The second aspect is that we also know that a decimal number is made up of fractional part, which is the whole number part, and decimal part. So I can say that this is going to be 0 plus how many numbers recurring? That is 3. So I take away what? 9. I take away 1. So it's only one number that is recurring. So that is going to be 3 over 1 minus the 10, which will give me this. You know, 0 plus every number give you a 3 over 9, which is still what? 1 over 3, as we have gotten for the first one. The second one is going to be that I'll have 0 as the whole number plus 42 over, this number is the one recurring, 2 of them. So we take away 1 from the 100. So I'll still get what? 99, which will still be 42 over what? 99, as my answer I have for question 2. Then what happened to question 3? Question 3, you can see that this is 0, but 1 is not recurring. So first of all, I multiply by my 10 for it to become this. To become 1.33 recurring. You see this? If you multiply this by 10, you get this. But if I leave the question like this, I've altered the, if I leave this here, it means I've altered the question. Because the question starts with 0. So I will divide by how many decimal places do I move? 1. So I divide by 10. Don't forget, if I divide this number by 10, I will get back to the original, meaning I have not changed the wording of the question. So from here, I'll be having one whole number plus how many numbers recurring? 3. So we take away 1 from 10 over this, all over what? 10. I don't know if you get this part clear. This whole of this represent the same thing. So I'm only taking the top to operate like a whole number plus fraction. Whole number plus fraction. And this is a fraction. 3 over 99. I know this is going to be 1 over 1. It is still what? 1. 10 over 10. So I'll use this one, 9, to multiply the numerator 1, the denominator 1. So I'll be having 9 over 9 plus 3 over 9. All over 10. Don't forget, 9 over 9 it still remain 1. No change in our fraction. A fraction that have the same denominator, we add the numerator, right? So in this case, I'll be having 9 plus 3. And that will give us what? 12. All over what? 9 divided by what? 10. But division could be changed to multiplication by flipping the second fraction. Don't forget, this is 1. I've explained why we flip that in one of my episodes. Check it out. So this is going to be 12 over 9 times 1 go up, then 10 come down. So 12 over 90, as we have per the mental calculation. So number 3 will be 12 over 90. All right. Then the number 4. Using the same approach, you can see this is already having a whole number there. So it's going to be 1 plus, this is going to be 15 over 2 decimal places. no non-recurring number, so it becomes 99, meaning we take away 1 from the 100. No division by 10, because this is exactly what we are having here. This whole number plus this give it the original. So I need to express this to have the same denominator. So that is going to be 99 over 99 plus 15 over 99. I believe by now you've gotten why I have this. I want to express 1 to have the same denominator as 99. So I'll multiply the top and down. 99 divided by 99 give me 1. So quotient has not been changed. Now I have the same denominator. So my fraction at the top can be added. So 99, 5, so 4 plus this. I have 114 all over what? 99. I believe you have 114 over 99 for the question number 4. So at this point, I'm sure you are gathering momentum to solve the 5th one. Alright. The first method that we did is mental. You know, mental cannot be used to solve questions to award marks. That one is only for section A, or if you are asked a quiz. The second method we did can be used to receive marks. Method can be shown. Alright. The third method could also be that we let our first 0.33 recurring to be our first equation. Okay, let me put it this way. Let x equals to 0.33 recurring. That is your first equation. We always want the recurring number to be part of the whole number. So the only way you can move it is to multiply by 10. So multiply through by 10, meaning I have 10 times x. 10x, 10 times they give me 3.33 recurring. Somebody will say, why am I still having 2 as I have here? Don't forget there are numerals of the 3 here. 3.333. I decided to use only 2 decimal places. So I want to have the same 2 decimal places. So now I have 2 equations. The number recurring is now part of my whole number. So I'm going to subtract equation 1 from equation 2. So we have equation 2 minus what? Equation 1. 10x minus x give you 9x. Then whole number 0 will take away from 3. Decimal from decimal. So 3 minus 0. 3. 3 minus 3 will go. So since we are looking for the x, we divide through by the 9. So your x is going to be 3 over 9, which is 1 over what? 3. Same as we have for the first question. So you can either use the equation approach, whereby you multiply to make sure your whole number, the recurring number, become part of the whole number. You can use that approach or use the second approach. Question 2. So we are going to have this 4, 2, 4, 2 recurring. That's the first equation. Let me use bar, meaning that 42 is recurring. Equation 1. How many numbers are recurring? 2. So I want all the 2 to come here, meaning 100 will be the powers of 10 I will use to multiply this. So 100 times this give me 100x equals to 42.4242 recurring. And that is our equation 2. Do we have all our numbers recurring as a whole number? Yes, 4242 is the number recurring. So we have it there. So we go ahead and subtract equation 1 from equation 2. 100 minus 1. This is 100x, 1x. That gives you 99x equals to 42 minus 0, 42. 4242 minus 4242, 0. So we have 99x, 99, 42, 99. Dividing both sides by the coefficient, this will cancel. X equals to 42 over 99. And that is also what we have for question number 2. I believe you are following. Alright. So the next will be number 3. Going to be 0.133 recurring as our first equation. Bear in mind that the 1 is not recurring, so we move it first on its own by using powers of 10, 1. So I have 10x equals to 1.33 recurring, equation 2. Do I have my number recurring as part of whole number? No. So I multiply by how many are they? 1. So I multiply by 10. So equation 2 by 10 will give you 10, 10, 100. Then I have 13.33 recurring, equation 3. The number recurring is part of my whole number. So equation 3 minus equation 2. 100x minus 10x. We have 90x equals to, this is 13 minus 1, 12, 3 minus 3, 0. So x will be 90x, 90, 12 over 90, dividing both sides by the coefficient. So your x is going to be 12 over 90. I know there's a common factor for this because of 0, 2. We can have a 2 going in there. 6, 2 go here, 45. So we can have this as our answer. But x is the same as what we have. Alright.